Welcome to Skillzam, a cure platform, cross-skill, upskill, reskill, and expert skill. We are your best learning partner for life. Skillzam, keep learning. Welcome to Skillzam section on bits and bytes. In this section, you will learn about the basic units of information and how do computers represent data. Also know better about the ASCII character encoding and its limitations. Going further on understanding how does Unicode solve some of the major problems related to the foreign language character representations. Bit, basic unit of information. When we look at computer, we see text, images, shapes, videos, and others. To a computer, all of that is just binary data, zeros and ones. You might be scratching your head at this point. Why do computers represent information in such a hard to read way? And how can ones and zeros represent so many different things? A bit represents a logical state with one or two possible values. These values are most commonly represented as 1 or 0, but other representations such as true or false, yes or no, plus or minus, or on or off are commonly used. A single bit can only represent two different values. That's not very much, but that's still enough to represent two valued states. Like for example, you can consider is a AC on or off? Is a port enabled or disabled? Is the current time AM or PM? A bit is a binary digit, a smallest increment of data on a computer. A bit can hold only one of the two values, 0 or 1, corresponding to electrical values of on or off, respectively. Physical representation of a bit. A bit can be stored by a digital device or other physical systems that exist in either of the two possible distinct states, like two stable states of flip-flop, two positions of an electrical switch, two distinct levels of light intensity, and so on. Bits can be implemented in several forms. In the modern computing devices, a bit is usually represented by an electrical voltage or current pulse or by the electrical state of a flip-flop circuit. Sequence of bits, nibble and byte. A single bit can only store two values. Bits are combined together into large units in order to hold a greater range of values. Computers use multiple bits to represent data that is more complex than a simple on-off value. A sequence of 2 bits can represent 4 distinct values such as 00, 01, 10, 11. A sequence of 4 bits can represent 16 different values. 4 bits will form a nibble. A sequence of 8 bits can represent 256 unique values. 8 bits is equal to 1 byte. A sequence can represent many things, a number, a character, a pixel. Plus, the same sequence can represent different type of data in different contexts. The sequence 1000011 could represent 67 in a calculator application, while it can also be representing the character C in a text file. Units of information. 1 nibble is equal to 4 bits. 1 byte is equal to 8 bits, which in turn is equal to 2 nibbles. 1 kilobyte, that is KB, is equal to 1024 bytes. 1 megabyte or MB is equal to 1024 kilobytes. 1 gigabyte or GB is equal to 1024 megabytes. Just to give you a comparison, 1 KB is approximately the memory needed to store one single spaced typed page. Representation of computer data. Be it a simple text file, an image, or a high-definition video file, everything can be represented by a unit of information. ASCII. ASCII stands for American Standard Code for Information Interchange, a character encoding standard for electronic communication. ASCII codes represent text in computers, telecommunication equipments, and other devices. Most modern character encoding schemes are based on ASCII, although they support many additional characters like the one in Unicode. ASCII code is a 8-bit code value, which means it has 2 to the power 8, that is 256 slots available. ASCII was first developed and published in 1963 by X3 Committee, a part of ASA, which stands for American Standard Association, which is now nothing but ANSI, which is American National Standards Institute. Any ASCII code can be converted to binary. Like for example, let's see, consider a character S, which has an ASCII equivalent code value of 083, which in turn is equal to a binary equivalent of 01010011. ASCII sections. As already understood, ASCII code is a 8-bit code value, which means it has 2 to the power 8, that is 256 slots available. ASCII table is divided into 3 major sections, like the first is non-printable values, that is system codes between 0 to 31, and lower ASCII values between 32 and 127. This table originates from the older American systems which worked on 7-bit character tables. The last section, which is nothing but the higher ASCII values between 128 and 255, this portion is programmable. Characters are based on the language of your operating system or program you are using. Foreign letters are also placed in this section. Limitations of ASCII and birth of Unicode. ASCII characters encodings has certain limitations, like it can only represent only 256 characters, and also all the foreign language characters cannot be represented. So, solution? Unicode is born. Unicode is an information technology standard for consistent encoding, representation, and handling of text expressed in most of the world's writing system. The standard, which is maintained by Unicode Consortium, defines 140K characters covering 154 modern and historic scripts as well as symbols, emoji, and non-visual control and formatting codes. Unicode can be implemented by different character encodings. Unicode Transformation Format, which is UTF, is a universal standard for mapping Unicode encodings. The Unicode standard defines Unicode transformation formats UTF-8, UTF-16, UTF-32, and several other encodings. UTF-8, the most dominant encoding on the World Wide Web, used over 95% of the websites as of 2020 and up to 100% for some languages. Binary representation of a character. Let us now consider an example of a text characters, that is Zami, which is the world's responsible social connect platform. This contains 5 letters Z, A, M, H, I. The ASCII code of a letter Z is 090. The ASCII code of a letter A is 065. The ASCII code of a letter M is 077. Similarly, for the letter H is 072. For the letter I is 073. The corresponding Unicode values are, the binary equivalent of the letters are. When storing the data in a computer, each character takes 8 bits, that is 1 byte, which means to store a word Zami as a plain text, it would take 5 bytes or 40 bits of data storage. Bitmaps represent an image in binary. Images are all around us, from application icons to animated GIFs to photos. Here's a simple image, a 16 by 16 heart icon. Let's zoom in and overlay a grid on top so that it's easy to see exactly which pixels are red and which pixels are white. A heart icon is made up of two colors, red and white. So a computer could represent it in a binary by mapping red pixels to 1 and white pixels to 0. This is called a bitmap since it's mapping pixel to bits. Using this method, the heart icon would be represented in binary values of zeros and ones. Even videos can be represented in the similar way. A video is an electronic medium for recording, copying, playback, broadcasting, and display of moving visual media. This section demonstrates that be it a simple text file, an image, or a high-definition video file, everything can be represented by a unit of information called bit. Thank you for learning with Skillzam and never stop learning.